Burning out this many components all at once is honestly not easy to do. A buddy sent me over a whole box of electric scooter chargers. Some of them didn't even have power cords anymore. Besides his own chargers, part of them belonged to his coworkers. He said, if they can be fixed, then fix them. If not, just throw them away. Some of these don't even have power cords, so they've clearly been sitting around for a long time. Let's take a look. There are a total of 9 units. First, I'll pick one that's relatively intact to repair. This one looks a bit newer. Let's see what the problem is. After opening it, the first thing I notice is that the fuse has already blown. I take the board out and have a closer look. This entire area is completely burnt black. When a fuse blows like this, the first thing we have to check is the rectifier diodes and the MOSFET. Setting the multimeter to diode mode, let's test these 4 rectifier diodes. The first one is already shorted. Actually, all 4 are shorted. No wonder the blast was so bad. Now let's check the MOSFET. The MOSFET is also shorted, which means the power chip is definitely fried too. Next, let's test the current sensing resistor. It's fine for now because its resistance is very small. If there were no beep, it would mean the resistor is blown. Then let's check this side, and we can see a resistor that has already blown open. Let's see what this resistor is. From here to here, and then through the rectifier diode, this is part of the secondary supply circuit. This resistor has already blown open. Now let's check this rectifier diode to see if it's okay. This rectifier diode is also shorted. Next, let's look for the drive resistor on pin 6 of the IC. On this side, the pins are number 2, 3, 4, 5, and 6. This one is pin 6. I flip the board over and it's this resistor here. This type of resistor usually has a relatively small value, typically around 10 to 20 ohms. Now let's remove all these burned components first. After removing so many parts, let's measure again to see if there are any other damaged components. Let's check the pull-down discharge resistor related to the MOSFET gate. 9.9 kiloohms, no problem. Next, let's check the startup resistor. This resistor is usually around 200 kiloohms or a bit over 100 kiloohms. This one is fine. Then let's check the snubber resistor. This one reads 46.5 kiloohms, also fine. Next, let's check the current sense resistor again. Earlier it seemed fine, but now it turns out this resistor is actually open circuit. The reason it looked fine earlier was probably because there was a short somewhere else. Normally, when the MOSFET is shorted, this current sense resistor will almost always burn out. I was wondering earlier why it hadn't burned. Now it makes sense. Next, let's check the current feedback resistor, 330 ohms. This one is fine. Now let's check the MOSFET gate drive resistor again. Earlier it seemed fine, but now it reads 20 mega ohms, so this resistor is also burned. Then let's check the bulk capacitor, 62 microfarads. This capacitor is fine. Now let's remove the current sense resistor and the gate drive resistor. At this point, all the burned components have been removed. On the primary side of the circuit, almost half of the components are damaged. The main components are basically all burned out. Now let's replace everything with new components. All the damaged parts have been replaced. Let's power it up and see if it works. The indicator light turns on. Now let's flip it over and check the voltages to see if everything is normal. First, let's check the output voltage, 70.2 volts, normal and stable. The label on the charger says the output voltage should be between 64 volts and 74 volts, so this is correct. Next, let's check the 300 volts, 314 volts, also normal. Then let's check the IC supply voltage, 11.4 volts, no problem. Let's check the 5 volt reference voltage, also normal. Next, let's connect a dummy load to see whether the indicator light turns red and whether the cooling fan starts. With the load connected, the light turns red and the cooling fan starts running. The multimeter shows an output voltage of 73.8 volts, normal and stable. So this charger is now fully repaired and working properly.